Hello everyone, I've split this into two parts and I'm trying to cover an awful lot of information and I've left an awful lot out. And it's not just papers and presentations, it's dissertations as well and theses. And I've mixed up together a whole load of stuff, but I hope you enjoy it. It's meant to be fun and you're meant to learn. So let's start. Okay, I let the designer pick this, and I've left it here because it just shows what garbage you can come out with, and this is actually really distracting, and you'll notice this is less than 20 point. Okay, maybe I'm being very greedy, wanting it more than that, but a general view is don't have anything less than 20 point on a slide and try and have everything meaningful. Okay, with any sort of presentation, be it a PowerPoint presentation or any other thing you want to use, or your paper you're trying to write, or an abstract for a conference, or even your thesis or dissertation. It's all about communication. Okay, now I'm not really going to deal too much in well, I will, too much about sentence construction, but let's look at the basics. You should avoid fancy and distractive fonts, okay? Rather use sans serif, which is a sans serif font, Calibri, most of my stuff is in Calibri, or Arial. I just like Calibri, I think it's attractive, and the letters are a little bit more spread out than Arial, and it's nice and clear. Do not ignore standard conventions, okay? Do not use a silly, unreadable font unless you're trying to get a point across. And on PowerPoint, uppercase is more difficult to read than lowercase because lowercase has got more variation. Okay, I'll put it in a silly font as well. Be very careful of animations. They can be very distractive. They can get really irritating. They can get really, really irritating. So use them very sparingly. Otherwise, people might just laugh at your presentation. So don't do it. Right, your abstract of your paper or your dissertation or your thesis, although it comes first after the authors and their affiliations, write it last because now you know what's gone on. Okay, so it's much easier to write last because you've done all the thinking. So most things I usually start with the references and put them together as I'm put them together, and then I start writing it, usually in order, but I leave the abstract to last. Basically, the abstract is a short summary of the findings found by the major techniques used. It's about 300 words. You might have more or less depending on what you're trying to do, but usually it's about 300 words. And what is it for? It's used by potential readers of the papers to see if the paper is of interest. Okay, so some people might not get past the abstract. If it's a bad abstract, they might not even get through the abstract. Your introduction, this is really important. Be relevant, be concise, use short, concise sentences. This one is using short sentences, but there's a lot of repetition here, okay? So you can rather have a slightly longer sentence, but actually say things much more succinctly and clearly. And in your sentences, don't use inappropriate words. Some people seem to think that you've got to use unusual words to sound learned or something. No, scientific communication is all about being succinct and clear. Okay, so here's trying to unpack that a bit more and be useful. Avoid repetition. This is just a repetition of that. People get really fed up of reading things again and again. And you might think, oh, repetition is good to get it across. Well, in a paper, the person can go back and look at it again if they don't understand. And And believe me, I read lots of students' work, I review quite a lot of papers, and I get so sick of repetition and long-windedness. Your literature survey. In a paper, this might be in the introduction, but in a thesis or dissertation or report, it's likely to be separate. So it's a literature survey, so use references, at least one per paragraph. Okay, ensure that the literature survey is up to date. That's one of the worst sins that you can do. Include relevant research. Use appropriate terminology. Remember, it's got to be clear and spell correctly. This was from a paper that I was reviewing, and I couldn't work out what a squeletum was. And I sort of mulled this. I looked it up. I couldn't find it. And then I was reading something else, and it suddenly hit me. A skeleton of tungsten carbide. So check things. Word is very good. That if you set it to do it, it will give you a little squiggly red line under things it doesn't know. Now, if it's a sort of jargon that you know, like microstructure, I don't think Word likes, or metallography, or I think it doesn't mind metallography, but it doesn't like metallographic. So check those. Check them very, very carefully, because you could be spelling it wrong. References. Use references properly. Okay. Few reports. Well, what are they? Name them. And then in a reference, don't put the authors in, but you do need a comma between the authors' names and the year that they were published in. And then be consistent. There's nothing worse than inconsistency. So really, you shouldn't have the initials in anyway, but they've got the initials in. So here they are after the surname, here they are before the surname. They don't always put a full stop with et al. I think there's one there. There isn't. Well, I've put it in, but be correct. There's no space there. It's just a mess. Okay. So always be consistent. And here's more lack of inconsistency. Sometimes you've got a full stop, there you've got a comma, there you've got a full stop and a space and a full stop. Here you've got all sorts of strange things, like the initials, no space after the authors, okay? And then here you've got the initials before the authors. Be consistent. Here you've got the journal name, not in italics, and here you've got it in italics, so be consistent. There's nothing more irritating to a reviewer or an examiner than inconsistent references. You can be wrong, but if you're consistent, being inconsistent is probably worse than being wrong, using the wrong format. If it's consistent, you can usually get away with it. Of course, the information has to be right, otherwise nobody will ever find them. Experimental procedure. Mention all your techniques. If it's a technique that's commonly used, you just have to say the technique and explain your techniques. Again, if it's a common one, you don't have to say too much. Only show diagrams or photographs of custom-made kit, but don't do it of commercial equipment that you can buy, okay? Just name it, give the make and the model, and sometimes people like to put the country that it comes from. That can be tricky if it's made in different places, but usually the company is based in one place, even if they've got factories all over the place. Report your experimental procedure in a logical order as you did the experiments. So you'd probably start off with where you sourced your raw materials, how you made your big samples, how you cut them up into your small samples, and how you prepared those small samples for the particular things you were doing. And remember to do it in a logical order. So don't talk about analysing them before you've made them. And then it's helpful to provide the limits of the techniques. if you know them. And if you don't, go and find out, because that could help later in the discussion if you get strange results. Don't show unhelpful diagrams. I mean, this is taken from the side. This is, I think this is supposed to be at least round the top of it, or cylindrical. And I love this because not only is this useful, somebody else has already written else remove. And please cite the figure, okay? So this is just rubbish. So get rid of it. Your results. Again, present your results in a logical order. Don't leave out any relevant results, and don't include results that aren't relevant. Describe your results clearly, and if you can, tabulate them, because it's easy to compare. If you've measured something, you should measure it more than once, at least 3 times, if not more, so that you get an average, and then you can report it plus or minus the standard deviation. Then you can see how representative your results are, and draw sensible graphs. State what any figure shows in the caption. Don't describe it in the text. You refer to it in the text with minimal description. You might say what you've gleaned from it, but the caption should say what it's showing. There's nothing worse than seeing a figure and thinking, what the hell does this mean? What's that line? Because it's in the text somewhere. It should be in the caption. So here's some figures. This one's not very good because you've got the legend or the key over the graph. That's just silly, okay? Put it to one side if it won't fit nicely down there. That's because there's a lot of things going on in this graph, and you might want to swap to split this graph up and plot it as 2 graphs. Now this is quite nice because you can see that you've got various results with error bars. So you can see that these 2 are quite similar because their error bars overlap. These 2 are quite similar, and these 2 are quite similar. These are quite different, and that one's quite different. Okay, so error bars really, really help. Right, a big thing that people do wrong, it's a big trap, is when they analyze things with the SEM. And I've come across so many things where people are analyzing phases and things which are too small. Okay, so 2 microns is the magic figure. Try and aim to analyze things that are larger than 2 microns. And the reason is that when you got an electron beam, it interacts with the sample. That's 2 microns. So if you look at this, this is about 2 microns across, and it's also about 2 microns deep. Now people might say, but it depends on the accelerating voltage. Yes, it does. But 2 microns is a nice, is about average. Okay, so here we've got a 3 micron bar. So what I've done is I've drawn little circles and placed it over where things were analysed, and you can see it's all right here because that's all in the matrix, but here it's going to pick up part of the matrix as well. Here it's going to pick up the other side of this and the matrix. That's going to run into this eutectic. These, you've got 3 things they were analysing there, and you can't separate them because they're too small. And what happens is people analyse loads and loads of times and think, well, I've got a small standard deviation, so I should be all right. But they're analysing the same wrong thing every time, so the standard deviation will be the same. Okay, another thing, make sure your EDX results add up to 100%. Always check. Yes, there might be a rounding error, but when you present them, they should add up to 100%. One of my colleagues loves checking this, and I got very lazy because I used to let him check it, and then one time I forgot he wasn't checking it, and it was a mess. Don't analyze holes, because what happens is part of the signal gets lost, so you won't get, it bounces off the side of the holes. You won't get accurate readings. Here's another example of analysing things that are too small. There's a micron, so there's your 2 micron radius. And just look, you're picking up all sorts of things. You're not picking up those 3 different phases that you think you're picking up. Okay, but of course, if you do it loads and loads of times, you're going to get similar values because you're picking up the same 3 phases, and you might think your results are really good. They're not. Okay, here we are, same thing again. These are even smaller, and the person's gone ahead and spent ages analysing all these, but they're garbage. Okay, another thing is, do not report things to too many decimal places. EDX is actually only accurate to less than 1 decimal place, really, but we do report it to 0.1, you know, to the first decimal place. So here they're reporting to the 2nd decimal place. Now, I know the manufacturers give it to you to the 2 decimal places, but you can rely on the fact that really you're not going to get that unless you've been really, really careful with standards, and you're actually using TEM rather than SEM, so you've got a thinner sample and you're not picking up anything. So I never believe things that are reported to 2 decimal places. So thank you very much. Most of this, I didn't make up this stuff, and yeah. So basically, thank you very much. And I do this as part of my job, but that does allow me to sometimes go away and do other things and try and find these things. And he was making a drink for me, but sometimes I wish I just stayed in bed. Thank you.